So here's a little talk. This is lecture 21 in thermodynamics. It's just ways of looking at delta H. Delta H has different names. It could be called heat of reaction, reaction enthalpy. I suppose it's important just to remember, it's been covered before, but there is no such thing as an absolute enthalpy. So chemists just defined the lowest energy form of atoms as having zero enthalpy. And so what matters to chemists is enthalpy differences. So this delta H is what matters to chemists, not so much H. So if you look at ways of looking at delta H, delta always means final minus initial. And so this has been covered several times, but that in chemistry normally means H of products minus H of reactants. So products are lower in energy than reactants. Delta H is negative. That's the first thing. And then the second little thing about delta H is in an exothermic reaction, the products possess lower energy than the reactants. So delta H is negative always in exothermic reactions. And finally, they often graph reaction progress like this. That hump is that there's a certain amount of activation energy that prevents reactants from automatically becoming products. So that's what the reason for that hump. But if you're just comparing the placement and energy of the reactants to the products, if the products are lower on this energy scale than the reactants, that's going to be an exothermic reaction. And if the products are higher on this energy scale versus reaction progress, that's going to be an endothermic reaction. And so those are three ways of looking at delta H. And this would be a negative delta H, and that would be a positive delta H. So, some of these little talks are just to help clarify things, because there is always a bunch of stuff going on in a complete year of chemistry course. Thank you.